Okay, this video is going to deal with questions from sections H1 and H2, where we work with polar coordinates. So I'll do a few of the homework problems from H1 and then a couple of the homework problems from H2. Oh, see, that's not on the screen. Hang on a second. Let's see if I can fix this here. There we go. So starting off, question number 1 says plot the point whose polar coordinates are given, then find two other pair of polar coordinate points for this point, one with r greater than 0, one with r less than 0. So question 1, we're given for part A, we're given the point 2 pi over 3. Now remember, that's r theta. So if we draw this point, we have r is 2 and theta is pi over 3. So we have pi over 3 here. That's our angle. And we're going to go out 2. So this is our point right here. If this angle right here is pi over 3. So they want us to express this point in two other ways, one with a positive r and one with a negative r. It doesn't say anything about whether theta has to be positive or negative. So whatever we do, starting here, remember the pole is here and our polar axis is here. We just put the x-y axis down to help us. So if we have to re-express this point in two different forms, one with an r greater than 0 and one with an r less than 0. We'll do r greater than 0 first. There's an infinite number of ways to answer this question. One way is we could rotate around a full rotation and then go pi over 3, right? A full rotation would be 6 pi over 3, because that's 2 pi. Then one more pi over 3. So we could write this as 7 pi over 3, our 6 pi over 3 for our full rotation, plus another pi over 3 to get us 7 pi over 3. That would work. We could do it, and we could use a negative r, right? Instead of, sorry, not a negative r. We could use a negative angle. We could go this direction. That would give us an angle of negative, right? Negative 5 pi over 3, because we're going clockwise, and then r would be 2. So any combination, you can add 2 pi after 2 pi after 2 pi, or subtract 2 pi after 2 pi after 2 pi. You're always going to end up at the same point. What about if r is less than 0? Well, remember what we said, r less than 0, this means reflection through the pole. So we would want, if r is less than 0, we would want to be here with our angle, and then when we reflect through the pole, we would land on the black dot. So our r would be -2, the -2 meaning we're going to reflect, and then our angle would be, well, it would be pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. So that's one way we could do it. And that angle would be 4 pi over 3, right? That angle would be right here, 4 pi over 3. But another way we could do it, if we didn't want to do it that way, because again, it didn't tell us the angle had to be positive any place, we could come to this direction. That would be -2 pi over 3. That would get us clockwise to that pink line, and then a -2 to reflect. Okay, so that's number 1A. I'm not going to do number 1B and number 1C. They're essentially the same question, just more practice. So that'll get you started on question number 1. Question number 3 says plot the point whose polar coordinates are given, then find the Cartesian coordinates of that point. So in question 3, in part A, we're given the point 1 pi. Now, if we plot that point 1 pi, we know our angle is pi, so that our angle is right here, and r is 1. So this distance here is 1. Now we know the Cartesian coordinates at that point. We don't have to use any of our formulas to find them. We know because we're on the x-axis, we went 1 unit to the left because our angle is pi. We know the coordinates at that point in Cartesian coordinates are -1, 0. So in part A, we didn't have to do any arithmetic to try to find the Cartesian coordinates. But if we look at a problem like B says 2, right? R is 2, and theta is -2 pi over 3. So how would we find this? Well, if we plot this, first we're going to use our angle of -2 pi over 3. So that's going to put us right here. And then R is 2. So here we are. We're right here. This is our point. Remember, this is R equals 2. Now, one way we could do this is we could just draw the triangle. If we know this angle right here is 2 pi over 3, then we know this angle right here is pi over 3. Because the distance all the way to here is pi, and that's a 30, 60, 90 triangle. The radius, sorry, the hypotenuse is 2. So the short side has to be 1, half the radius. And then the long side is the square root of 3 times the short side. So we could find the coordinates that way. And we could say, okay, well, our Cartesian coordinates are -1, -√3, because we have to remember we're in the 3rd quadrant. Now, another way equal to r sine of theta. From here, we could plug everybody in, right? X is going to be equal to r, which is 2, cosine -2 pi over 3. And y is going to equal 2 times sine of -2 pi over 3. And if we do our arithmetic here, our reference angle, going back to our pre-calculus days, we would draw this angle. Our reference angle is pi over 3. And so if our reference angle is pi over 3, then we would have, our standard 30, 60, 90 triangle would look like this. 1, 2, square root of 3. And we would have a reference angle of pi over 3. Now, pi over 3 is here. So that would equal 2. Cosine of that is going to be adjacent over hypotenuse. That's going to be 1/2. And then we would have to remember that all students take calculus. Cosine is negative in the 3rd quadrant, and that would get us our -1 that we got right there. Similarly, over here, we would have this is equal to 2. Sine of 2 pi over 3. Again, your reference angle is pi over 3. Sine is √3 over 2. Again, in the 3rd quadrant, sine is negative. When we multiply that out, we would get -√3. So that's how you do problem number 3. I'll leave part C for you. So let me erase these. Question 5, again, has parts A and B. I'll do part A. Question 5 says, A says we're given the point 2, -2, and the directions are find the polar coordinates for r and theta, where r is greater than 0 and theta is negative. It's sorry, theta is positive between 0 and 2 pi. So they want us to find the polar coordinates, and they give us the conditions that r is greater than 0 and theta, now this is part I, theta is between 0 and 2 pi. So if we plot our point, this is our Cartesian point. So this is x is 2, y is -2. We're right here. Right, remember, this is 2, this is -2 here. And they want us to find the polar coordinates for that point. Now, we could do it just by looking at this and realizing that this is a 45-degree angle from our days back in algebra or geometry or something. We want r to be positive, and we want theta to be bigger than 0 but smaller than pi/2. So this is going to be our theta. We want it to be positive, so we have to go counterclockwise. And we can figure out how big this is. We can think to ourselves, well, that's just a triangle, right? That's a triangle. This side is 2, and this side is 2. So we could use the Pythagorean theorem, or if we know the Pythagorean theorem in our head, we could say, well, that side's going to be 2√2, or we could use the Pythagorean theorem to find it. So we could do this with geometry, or we could use our formulas, right? Remember, we have formulas. We have a formula that says r squared equals x squared plus y squared. So r squared is going to be x, which is 2 squared, plus y, which is -2 squared. Now that's going to equal 4 plus 4, that's going to be 8. So r, when we take the square root, r, now they told us we want r to be positive, so we're going to take the principal root and get r equals 2√2. Now we need theta. We know what theta is from looking at that, right? We know this angle right here is pi/4. So we know this angle, theta, is equal to 7 pi/4. And so our point, right, our point in polar form is 2√2 7 pi/4. Now, we could use the rule that says theta equals the inverse tangent of x over y, which in our problem is going to be the inverse tangent of x this is supposed to be y over x, right? My brain is screaming at me like you were screaming at the screen. So this is going to be -2 over 2. Now we have to do some analysis here, some of our pre-calc thinking. We know that's inverse tangent of -1. Inverse tangent is defined in quadrants 1 and 4, right? 1 and 4. So we would need the inverse tangent of -1, which we would say is -pi/4. That's what we would say if we were in pre-calc. But we know we were told we can't use -pi/4. We have to use the positive version. So we would have to convert that to 7 pi/4 just by knowing the conditions that they gave us. So that's part I. Part II simply says, find polar coordinates for this point again, but our conditions are different now. R is negative, and theta is still between 0 and 2 pi. So here, we're going to build on what we did here. We know what our value of r is. Our value of r is 2√2. That's our absolute value of our magnitude. That's how long this is going to be. But we need our r to be negative. So the only way we can force r to be negative, remember, if r is negative, that means to reflect. So our point has to be here, right? Which means our angle is going to be this angle right here, since it has to be positive, and that's going to be 1 pi/4, right? I'm sorry, that's going to be 1 pi/4, 2 pi/4, 3 pi/4. So we're going to have -2√2. That's going to bring us across the pole. And the angle we're going to begin with is going to be 3 pi over 4. All right, so that's how you get going on number 5. Let me go ahead and erase these. Questions 9 and 10. I'll take a look at number 10. Okay. Number 10 says, sketch the region in the plane consisting of the points whose polar coordinates satisfy the given conditions. So we have 2 is less than r is less than or equal to 5. So our radius is between 2 and 5, open at 2. And our angle is between 3 pi over 4 and 5 pi over 4. Less than theta, less than 5 pi over 4. And all they want us to do here is to sketch this region. They want us to draw this. So if we put our axes on the board, we know we're working between 3 pi over 4 and 5 pi over 4. Those are our angles. Those are dashed lines because those do not equal, right? Those are strict inequalities. Theta is bigger than 3 pi over 4, but less than 5 pi over 4. And now my radius goes from 2, and I'll just define this to be 2. I'm going to make this dashed again because of the lack of inequality there, all the way to 5. And that's solid. So that radius is out here. So this is the region that corresponds to those conditions for r and for theta. Not including these lines, not including this arc, including this arc, and all the points in between. So everything in here, everything in here. Okay. So the problems that we've looked at so far are just there to try to get us some degree of comfort with polar coordinates. That's the purpose of these questions. They're kind of just intro questions to get us some degree of comfort. Now, question 13 says, identify the curve by finding the Cartesian equation for the curve. So in problem 13, they give us r equals 3 sine of theta. And they want us to identify the curve. Now, there's a couple of ways we can do this, right? One way we can do this is we could say to ourselves, well, I'm going to plot points. And there's nothing wrong with that. If we do plot points, right, we'd put a theta here and we put an r here. And we'll start with theta is 0 and then maybe pi over 3 and pi over 2 and 3 pi over 4. We'll just put some random points down here in pi and we'll see what we get. So when theta is 0, we get sine of 0, which is 0 times 3. That's going to be 0. When theta is pi over 3, now remember, pi over 3 is our reference angle, right? So pi over 3, this is 1, 2, the square root of 3. This is pi over 3 here. So when theta is pi over 3, we're going to get sine, which is going to be root 3 over 2. And so we're going to have 3 root 3 over 2. When theta is pi over 2, we're going to get sine, right? Sine of pi over 2. Sine of pi over 2 is 1. 1 times 3 is 3. At 3 pi over 4, now we need a different triangle, right? 1, 1, square root of 2. This is pi over 4. So 3 pi over 4 is in the third quadrant. We'll have to keep that in mind. Sine's positive in the third quadrant. So sine is going to be opposite over hypotenuse. That's root 2 over 2. times 3. So that's going to be 3 root 2 over 2. What about when it's pi? Well, when we're pi, right, when we're pi, at pi, sine of pi is 0, 0 times 3 is 0. So what do our points look like, right? Where do our points lie? Well, when theta is 0, r is 0, so that puts us here. When theta is pi, so on this is 0, right? This is pi. So when we go on this angle, we go 0 digits away, 0 units, 0 is our distance away from the pole. On pi, we go this way, 0 is our distance from the pole, so we're on the pole. At pi over 3 is here. We're going to go out 3 root 3 over 2. We'll just put a line and say this is 3 root 3 over 2. At 2 pi, right? At pi over 2, we're going to be 3, right? That's going to be our distance. Our distance is going to be 3. So is 3 bigger than or smaller than 3 root 3 over 2, right? Do I make it longer? Do I make it shorter? If you're not sure and you don't remember, the way you can do that is you can just take your 3 root 3 over 2 and your 3, and you can square both of them. When you square this one, you get 9. When you square this, you get 9. When you square this, you get 3. And when you square this, you get 4. And that's 9 times 3, that's 27 over 4. And 27 over 4 is 6 3/4, right? Because 6 times 4 is 24. So this number, 3, is bigger than this. So we're up here. At 3 pi over 4, right? At 3 pi over 4. Now 3 pi over 4 is here. That's 45 degrees. We're at 3 root 2, 3 root 2 over 2. 3 root 2 over 2 is smaller than 3 root 3 over 2. So we're going to be back down here a little bit. So if we look at this and we think to ourselves, well, I really don't know what that is. That's true. You don't, because we haven't plotted very many points. So if you really want to identify this, maybe plotting points is not your best idea. So another approach, right? Another approach you can use is you can use your equations, right? We have 4 equations. We know that x equals r cosine of theta. We know that y equals r sine of theta. And we know that r equals x squared plus y squared. And we know that theta equals the inverse tangent of y over x. So perhaps, from here, we can do some arithmetic with our given problem and see what we get. So if we take a look at what we have here, if we take a look at what we're given, if it looks a little strange on the screen right now, I had to pause the video because my green pin exploded. And so it started making a mess. So that's why these suddenly appeared in the middle of the video. While I was cleaning up the mess from my green pin, I noticed that I forgot to put r squared equals x squared plus y squared there. So if plotting points isn't going to help us, right? If that's going to cause us more confusion than it's going to cause us assistance, we can use our equations. So we can take a look at what we're given here, right? We know that if we solve this for sine, we can take r equals 3 sine theta, and we can transform that into r over 3 equals sine theta. But from this equation right here, we know sine of theta is equal to y divided by r, right? Because we can move this r under the y. Now, if we cross multiply here, right? If we get the sine, just act like that's not there, and we cross multiply, we get r squared equals 3y. But we know r squared is x squared plus y squared equals 3y. That gets us x squared plus y squared minus 3y equals 0. And now I'm going to complete the square on this. I'm going to divide this by 2. That's negative 3/2. I'm going to square that. That's plus 9/4. So that puts a 9/4 there, which of course, by our rules for completing the square means I have to put a 9/4 there. And now we have a circle. We have x squared plus y minus 3/2 squared equals 9/4. So we have a circle, right? Center is at 0, 3/2. And the radius equals the square root of that, which is 3/2. So if we take a look at our picture, right? If we take a look at our picture, the center, remember this was 3, right? This was 3. The center is going to be at 3/2. That's right there. And our radius is 3/2, which makes sense. Our radius is 1.5. So that would have got us to here and here. So we would have had this circle that looks like this. Now that was hard to tell from those points. So using our equations and simplifying or converting our polar form to our Cartesian form is a better approach. Okay, let me erase this along with this green explosion here. All right. In problems 17 through 20, we have to do 17 and 19. It says find the polar equation for and they give us their Cartesian form, right? Like on problem 17, they tell us x is equal to negative y squared. Well, we have our equations. We know x is equal to r cosine theta. We know that y is equal to r sine theta. Don't forget the negative. And so we get r cosine theta equals negative r squared sine squared theta. And if we divide both sides by r is greater than 0. If we divide both sides by r, we get cosine of theta equals minus r sine squared theta. And now we can move the sine squared over here and the negative, and we get r is equal to, and then when we move the sine over here, we're going to get minus cosine theta over sine squared theta. Now cosine over sine is all right. Questions 23 through 42 ask us to sketch the curve with the given polar equation. All right. Sketch the curve with the given polar equation. I'll do one of these. We've already done one, right? We did one of these earlier. There aren't very many different types of problems in this section. So hence the reason he's, duplicating them. If we look at, we'll look at 31. All right, we'll look at problem 31. Problem 31 says r is equal to 4 sine of 3 theta. And they want us to sketch this curve with this given polar equation.